So, hello everyone. Today we discuss the worksheet 3 on redox reactions. Okay, see the second question in it. The oxidizing agent in the following reaction is what? So, here the reaction is potassium iodide reacts with I2 forming a potassium triiodide, that is Ki3. So, by seeing these oxidation numbers, we can say here oxidation number of iodine -1. Here oxidation number of iodine 0. Here oxidation number of iodine. We know that the potassium is always 1 only because it belongs to 1A group elements. So always for potassium only one oxidation number. So the oxidation number of each iodine in this is -1/3. So comparing these values, we can say here potassium iodide is oxidized. Potassium iodide is oxidized and I2 is reduced. So the question is, what is oxidizing agent? So I2 reduced means so it is reducing, so it is oxidizing agent. So oxidizing agent means which itself undergoes reduction. Here I2 undergoes reduction, so it is oxidizing agent. Okay, see the fourth problem in it. So the question is in the reaction of ozone with hydrogen peroxide, or in the reaction of ozone and hydrogen peroxide, the latter acts as. So here, so the question is in the reaction of ozone and hydrogen peroxide, latter acts as means the two compounds are given. We have to find about this one. Lateral acts as means the question is about hydrogen peroxide. It works as oxidizing agent, reducing agent, or bleaching agent. We have to find that. Okay, if you see the reaction of hydrogen peroxide with oxygen, with ozone, there is a formation of O2 and H2 are there. So on balancing, we will get so 2 hydrogens, total how many? 5 oxygens. Okay, so here see the oxidation number of oxygen -1, here it is 0, here it is -2, here also here oxygen oxidation number 0. So if you observe all terms, we can say here H2O2. Here H2O2 works as a reducing agent. Okay. Hydrogen peroxide. Hydrogen peroxide acts as reducing agent. Okay, because the hydrogen peroxide itself it is oxidized. Hydrogen peroxide itself it is oxidized, so we can say it is works as reducing agent. So what is the importance of this question is generally hydrogen peroxide acts as oxidizing agent and also reducing agent. Okay, it has both properties, oxidizing properties and reducing properties. So in this particular reaction, it works as a reducing agent. So here hydrogen peroxide acts as a reducing agent. So actually, so the important thing in this reaction is the oxygen obtained. The oxygen obtained is from hydrogen peroxide. So here means H2O2 itself it is oxidized. It means it works as reducing agent. So there is already we said there is two possibilities. For hydrogen peroxide we said it may work as an oxidizing agent or also reducing agent. So if the hydrogen peroxide, if it acts as an oxidant, nothing but oxidizing agent, it releases H2O. The hydrogen peroxide, if releases oxygen, it works as a reductant. Okay, see the question number 5. See the question number 5. So the given the question is the gas bleaches the color. So not the gas, it is given as one gas. One gas bleaches the color of flowers. Color of flowers by reduction. And other gas by oxidation. So the gases are. So actually we have to write the options also first. So the given options are sulfur dioxide and chlorine. Next carbon monoxide, chlorine. Next hydrogen sulfide and bromine. Next ammonia and sulfur dioxide. Here you see, so bleaches the color of the flowers means so generally we know there is a many number of uses with the help of bleaching agents. The bleaching agents, the main bleaching agents used in the industries are chlorine. Mainly in the textile industries, chlorine works as a bleaching agent. Okay, in some chemical reactions also sulfur dioxide also works as bleaching agent. So bleaching agent is possible two types. So some elements nothing but some compound works as bleaching agent with the help of means by working as oxidizing agent. Some compounds works as bleaching agent by acting as reducing agents. Here see the reducing agents. Here the bleaching agents are sulfur dioxide and chlorine. Sulfur dioxide and chlorine are the best bleaching agents. Okay, so we have to find which is works as by reduction, which is works as oxidation. So generally sulfur dioxide and with the help of its reduction reaction, sulfur dioxide with the help of its reduction reaction it works as bleaching agent, whereas chlorine works as its oxidation process. Okay, so due to the oxidation reaction of due to the working of oxidation, chlorine removes the color of the flowers. So due to the reduction process, sulfur dioxide removes the color of not only flowers, any color matter. Any color matter becomes any colored matter becomes colorless is called bleached, or which is used for its make it as a colorless is called bleaching agent. So here chlorine acts as the oxidation with the help of its oxidation property. It works as a bleaching agent. Sulfur dioxide works as a bleaching agent with the help of its reduction property. Okay. So to this we have to remember these compounds. So next, in which nitrogen is oxidized? So the question is, so there is options are given. We have to find in which change Nitrogen is oxidized. First change is given NO3, nitrate. Nitrate ion becomes nitric oxide. Next one, nitrate ion, it becomes ammonium ion. Next given ammonium ion, it changed to nitrogen. We will check all options. Nitrogen dioxide changed to nitrite. So we have to see the difference. This is nitrate, this is called nitrite. So in which nitrogen is oxidized? Oxidized means its oxidation number should increase, means it should lose electrons. Okay, so here what is the oxidation number of nitrogen? We calculate here. X minus x equal minus 1, x equal 5. So what is the oxidation number of NO? So here oxidation number of nitrogen decreased from 5 to 2. So it is a reduction, it is not oxidized. With the help of number of oxygens also we can say here easily. Here 3 oxygen, here only 1 oxygen, losing of oxygen, nothing but reduction. But generally the common technique we are using is oxidation number. Here nitrogen oxidation number already we calculated it as plus 5. So in ammonia, what is the nitrogen oxidation number? X plus 4 equals 1. So here also oxidation number of nitrogen plus 5 to minus 3 decreased. So it is also reduction. Here also we can say it loses oxygen, it gains hydrogen. It's a perfect symbolic of reduction. The importance of this transfer, what is the importance of this change is, generally nitrogen shows variable oxidation states. What is its maximum oxidation number is plus 5, its least oxidation number is minus 3. Its least oxidation number minus 3, its highest oxidation number plus 5. Here both are present, the plus 5 and minus 3 are present. Let's see here. So already we calculated the nitrogen oxidation number here is minus 3. So nitrogen 0. So it is from minus 3 to 0. So it is increased. So it is the option. It is oxidized. So compare this also. Nitrogen oxidation number how much here? So X is equal to 4. X minus 4 equal minus 1, x equal to minus 1, here we will get so here also nitrogen reduced. Only in the option C is the nitrogen is oxidized because its oxidation number increases from minus 3 to 0, or other terms we can say it loses hydrogens, so it is oxidized. Okay, so option 3 is the correct answer. Okay, see the next question. Here given MnO4 minus can oxidize NO2 minus to NO3 minus. So here we know that MnO4 potassium permanganate or permanganate ion works as oxidizing agent. In this problem it is given that permanganate ion oxidized nitrite to nitrate in basic medium. We had to find how many moles of NO2, how many moles of NO2 are oxidized by 1 mole of MnO4 minus. So if you know the total reaction, we can write the reaction. But now we have a technique that is comparing the equivalence or milli equivalence. If it is given in terms of molarity or normality, we can compare the volume, we can compare the milli equivalence. But it is given only in terms of moles. In terms of moles, each we have to compare their equivalence. We have to equalize their equivalence. Means these two are reactant, means we can write equivalence. The equivalence of MnO4 minus is exactly equal to equivalence of nitrate. Equivalence means we know that weight by equivalent weight. So we don't know about the weight. So have the information that is moles. So 1 mole of MnO4 minus. In terms of mole, what is the equivalence? Equivalence nothing but moles into n factor. Means moles into n factor, nothing but it is numerically exactly equal to the equivalence. So n factor of MnO4 minus, it is ours. So we have to find in terms of moles, కాబట్టి moles into n factor of NO2 minus. So how many moles are given for MnO4 minus? 1 mole. What is the n factor for MnO4 minus? We know that it is 3. So how it is n factor 3 means we know that it is given in basic medium. In basic medium, we know that the change in MnO4 minus is into MnO2. Here oxidation number plus 7, here oxidation number plus 4. What is the difference? 3. So therefore, means the transfer of electrons is 3. So 3. Moles, we have to find this moles of, to find the moles of NO2 minus, we are taking it as X. So n factor of NO2 minus. So NO2 minus given as change into NO3 minus. Then what will be the oxidation state difference? Here oxidation number of nitrogen is 3. Here oxidation number we will get 5. Okay. So therefore X equals 3 by 2. Okay. It is 1.5. Means 1.5 moles. 1.5 moles of NO2 minus. 1.5 moles of NO2 minus or oxidized into NO3 minus by 1 mole of potassium permanganate ions. Actually, these model problems are very important. Okay, see the 9th problem. It is also related to this one. So calculate the number of moles. Calculate the number of moles of permanganate ion required to oxidize. So already we know permanganate works as the oxidizing agent. Here to oxidize 1 mole of oxalate. 1 mole of oxalate in acidic medium. So it is also exactly similar to the last one, but here the question is we have to find the number of moles of MnO4 minus. So last problem manaki MnO4 1 mole ichhindu, NO2 minus moles find out cheyali. Here 1 mole of MnO4, so we have to find the MnO4 minus permanganate ions moles. The given is oxalate. What is the difference is the last problem is in basic medium, this problem is the acidic medium. So if the reaction takes place between the two chemical species, we can write so equivalence of MnO4 minus exactly equal to equivalence of oxalate. So it is given in terms of moles. We have to calculate in terms of moles. Probably equivalence nothing but moles into n factor. Again moles into n factor of C2O4 minus 2. Then see what is the moles of MnO4 minus. We have to find these moles. What is the n factor of MnO4 minus? That is that is 5. What is the moles of oxalate? Oxalate moles is given 1. What is the N factor for C2O4 minus 2? You have to do this calculation at right side, or you can write in normal calculation also. So in acidic medium, we know that MnO4 minus becomes Mn plus 2. Here manganese oxidation number plus 7 becomes plus 2. So therefore we return N factor equal 5. So what happened oxalate? The C2O4 minus is changed to CO2. What is the N factor? What is the change in the oxidation number? Here the 2x equal how much? 6. Here x equal to what? 4. If you take, we are comparing, we have to compare the 2 carbons. Means if you write the x, if you make it x equal 3 comma 3, means the 2 carbons are having oxidation number 3 comma 3. Here 2 carbons are having oxidation number 4 comma 4. Means what is the change in the number of electrons? 3 becomes 4 for one carbon. Second carbon also from 3 becomes to 4. Its oxidation number. Means both carbons are oxidized. Means how many electrons? The losing of 2 electrons. So that is equal, in fact, equal to 2. So what is x equal? X equal 2 by 5. So x 2 by 5 moles of MnO4 minus are required. Means we have to know how to calculate the N factor. Let's see the next one. So 1 mole of oxalate is oxidized by, so here the 1 mole of C2O4 minus 2 is oxidized by X moles of, it is given the X moles of Cr2O7 minus 2. This is dichromate ion in acidic medium. So I have to find what is the X. So again the same model, just here the agents are different. We know that potassium dichromate is also a good good oxidizing agent, just like KMnO4. So here we have to compare equivalence. Equivalence of dichromate equal to equivalence of oxalate So how many moles of Cr2O7 minus 2? So it's 1 mole. What is the oxidation N factor for Cr2O7? So I think it is its N factor is 6. What is the moles? We have to find that moles. What is the N factor for oxalate? So oxalate just now we calculated in the last problem, that is equal to 2. So here x equals to 3. Means the 3 moles of Cr2O7 oxidized by x moles of so what is x? Is x moles of dichromate. So it is given, sorry, the problem is different, not like this. So we have to find x value. So it is oxidized by x moles of dichromate. Means dichromate moles is X. Dichromate moles is given X and factor equals 6. What is the moles of C2O4 minus 2? That is 1. We take in totally opposite. So what is the oxalate? Oxalate 2. So here X equal to so 0.33 means 0.3 moles of dichromate are required. So then X moles of Cr2O7 X moles. Now the important thing is N factor. So N factor of dichromate Cr2O7 minus 2. So we must know the change. We must know the change in it to calculate the N factor. Or if you are able to remember the N factor, there is for many components fixed N factors are there in different mediums. So here the chromium oxidation number, if you calculate, that is 2x minus 2 here, 2x equal to 12. It means the two chromiums are in 6 oxidation numbers. Chromium plus 6, chromium plus 6. Here two chromiums are in plus 3 oxidation number. So one chromium plus 6 becomes plus 3. Other chromium plus 6 also becomes chromium plus 3. Total how many change in the electron? 6 electrons. Okay, plus 6 becomes plus 3. Okay, plus 6 becomes plus 3 means they totally gains 6 electrons. Then what about C2O4 minus 2? We know that C2O4 minus 2 changes to 2CO2. Here two oxidation numbers. 2x equals 6. Here for 2 carbons equal it is 8. So the change in the number of electrons is 2 electrons. Okay. Losing of the 2 electrons, that is the N factor. Means the knowing the N factor is the key point here. So knowing the N factor is the N factor for these problems. Okay. Let's see the last problem. See the question number 15. So the oxide, so it is a general theoretical question, so direct question. The oxide which cannot acts as a reducing agent, so we have to check the options. Okay, so already we know the same type of question, which cannot act as a reducing agent. So here only it's a direct question. SO2 actually these three works as a reducing agent, but SO2 works as an oxidizing agent. Means itself it is reduced. Means it undergoes reduction. Only it also works as a bleaching. It bleaches with the help of its reduction reaction. Means itself it is reduced. Okay. Itself it is reduced means it works as oxidizing agent. Okay, these are the total main problems in the redox reaction worksheet 3. You have to practice it at least 2 to 3 times. Okay.